One torture to another.
Exactly.
All right. These ones say, write the specified quantity as a function of the specified variable. It will help in each case to draw a picture. One leg of a right triangle is twice as long as the other. Write the length of the hypotenuse as a function of the length of the shorter leg. So we've got a right triangle.
Okay, I was like, I'm just gonna get a picture first. I'm very lost.
One leg is longer than the other.
So we know, well, we were told we had a right triangle. One leg is twice as long as the other. So the legs are not the hypotenuse. So one leg is going to be, I'm just going to call it h for height. And then this one is going to be 2h. And then it says, write the length of the hypotenuse as a function of the length of the shorter leg. So since we normally call hypotenuse C, I'm going to call it C up here. So how might I relate that? What is our typical formula that we use with a right triangle?
A squared plus B squared equals C squared.
Yes, the Pythagorean theorem. So C squared is going to be equal to h squared plus 2h squared. So then C is equal to the square root of h squared plus 4h squared. So C is equal to the square root of 5h squared. And then, what can I do?
Can we take out the H?
Take out an h. Is that what you mean, get rid of the square?
Kind of.
Okay.
I mean,
We're going to
actually, the
take out the h. So it's going to be C is equal to h square root of 5. And so that would be what relates. The length of the legs to the hypotenuse.
Can I ask a question?
Sure.
Because Lisa thinks that this is right. It's $10 a person for the things.
But it's
for
like
all the slots.
it's
the
each
numbers.
slot. It's not how many kids are working though.
But you're allowed 2.
Right, but you only get paid for one.
You get paid for 1.
It's $10 per game per thing.
10. Oh, which is
But what Tim Greer used to do, I don't know what happened last year, but what Tim Greer used to do is he would, and I only know this because it was my class, he would always give a little extra
you got
for
extra.
things being covered. He would give like $20 or $30 extra for covering things and all that.
We were trying to figure out because you got 400 and some. I always counted the people that we did, and we got that many. I have 52 people that worked, and so that's why we thought it was, because you got 400 and something.
Yeah.
And
Well, that was under Tim, and we had a little extra. I could go back and see how many games it was that were home games, and I could tell you.
because he wants to know for sure. And I said, they're thinking that it's $10 a person just because of the way the numbers have been. So, all right.
It's $10 a
$10
slot.
per slot. All right, so
Because there would be 2 games each time. So you can assume 4 slots a date.
So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20. I'll count them. But yeah, that would, okay.
That's what we did. Now, last year, I don't know if they were given extra or not. I know that Tim said every time he would give extra.
Okay,
Just because of having to deal with everything and all that.
okay, got it. Thank you.
Uh-huh.
Virginia's gonna be so confused.
Huh?
Virginia's gonna be so confused.
Virginia, please disregard the last 2 minutes.
It was just goody pie, and
I was like, who's at the door? Like, what are y'all? Because I was like, is it a kid? Like, who is it? And then she popped out. I was like, oh.
Because she looks at me and she points, she goes, yes. Or not me. Go, please.
See, I won't be seen by an intruder.
No, we'll be perfect in that little corner. Until the lock doesn't work.
That's scary.
Yeah,
Don't jinx it, Riley.
All right. 18. A square is inscribed in a circle. Bet you haven't seen that since geometry. Write the area of the square as a function of the radius of the circle.
Okay. Wow.
So I've got a circle. And inside of said circle, I have a square.
Yay.
That worked out way better than I expected it to.
Looks better than mine. I have like an oval, or maybe a weird egg. It's kind of flattened and wide.
The other day I tried to inscribe a circle in a square, and it did not go very well.
And then I have a weird trapezoid looking thing. Basically.
All right. The area of the square as a function of the radius of the circle. So, we know that the radius is from the middle of the circle to the edge. So, that means that this part of the diagonal of the square is the radius. If I did the entire diagonal, it would be the diameter. Okay? So I can also then do the same thing over here. And so this is radius, this is radius. What do I know about this angle right here?
It's a 90-degree angle.
It's a 90-degree angle, so it's a right angle. Jeez.
Lord.
And then this is going to be my side of my square. So what shape is that?
Triangle. It's a special one.
A right triangle, yep.
45,
So,
90.
just a couple things I'm going to note here. The radius is half the diagonal of the square. S is the side of the square. So I need to now find S. How might I find S? Yep, so S squared is equal to R squared plus R squared. So S is equal to the square root of 2R squared, meaning that S is equal to R square root of 2. So now, I know this, but I need the area of the square as a function of radius. So, what's the area of a square in general?
Side squared.
Side squared. So in general, A is equal to S squared. So now I'm going to replace S with R square root of 2. So this is equal to R square root of 2, and that whole thing squared. So this becomes 2R squared is my area. All right. We are going to do one actual word problem here, and it's actually going to be odd just because it's a good problem. So, 27. This is sale prices. I know why I do this. Because when you go shopping, I want you to be able to know how to find a sale price. That's why I do this problem. Because it really irritates me that people can't the easy way. There's an easier way than what most people do. So we're going to learn that. That's what we're going to do. At a shirt sale, Jackson sees two shirts that he likes equally well. Which is the better bargain and why? Now, I'm going to tell you, I wouldn't personally pick either of these shirts, but, you know.
Wow.
So we have a $33 shirt at 40% off, and we have a $27 shirt at 25% off, and we want to see which one's the better deal. So basically, I'm going to find the sale price, and whichever one's cheaper, or well, hold on, whichever one's the better bargain is what we're going to pick. So not necessarily which one's cheaper. It's basically which one ends up with more money off,
Yeah.
in a sense.
So.
Well, there's two ways to look at this. We'll look at it both ways. We're going to look at which one's cheaper and which one is the better sale price.
Okay.
Like, bargain. So, just because that way you can see it, two different things. So, the $33 shirt is 40% off. And the $27 shirt is 25% off. So to find the better bargain, we want to see which one has the most money off of it. Okay? And so I'm going to label this because we're going to do it two different ways. So the better bargain, I don't think that's how you spell bargain. Nope, it definitely has an A in it. Bargain.
Yeah, I don't know.
We're going to take the price of the shirt and multiply it. I'm hungry apparently. And multiply it by the decimal of this percent. Okay, so the decimal is going to be 0.4 for this one, 0.25 for this one. So 33 times 0.4 and then 27 times 0.25. So 33 times 0.4 is $13.20. And this is what's being taken off of the price. Then 27 times 0.25 is $6.75 off the price. So which one is the better bargain?
The $33 one.
The $33 one. So this one is the better bargain. Okay. Now, I'm going to show you how to tell what you would pay. Okay, because a lot of people don't understand this. And so what they tend to do is they'll be like, well, it's 40% off. So they'll do the 33 times 0.4 and then they'll take 33 minus 13.20. And so that's like 2 steps of math, but I can give it to you in one. So this one is going to be 33 times 0.6 because 0.6 is what I'm going to pay. I'm paying 60% of the price. So this one's going to be $19.80. So this is what we would pay for that one. The other one is going to be 27 times 0.75, which is $20.25. Okay, and these decimals are coming up as like 19.8. So obviously, because it's money, make sure you put, the 0 on there. So in this case, it's still the $33 shirt that ends up being cheaper at the sale price that it is, even though it was higher to start with. So it actually ends up being the same in both cases. That won't always happen, but it can. So he would obviously rather have the $33 shirt, which I guess it looks a little better than the $27 shirt, but anyways, but all that to say, when you go to a store, think about how much you're going to pay versus how much am I getting off, and then subtract that amount. It just saves you a step. And a lot of people don't know that, but that's what my mom taught me when I was younger, so that's the way I always do it. So, anyways, not that you can't do it the other way.
Yeah.
Just make your life a little easier. All right. That's all we're going to do, at least for now. We may end up coming back and doing some more with word problems at another time, but for now, that's it. So, did I give any problems yesterday? I did not. Okay. So, problems are 1, 3, 5, 9, 15, 21, 23, 25, and 29. No, 39. Most of these in the middle that you're probably like, we didn't do anything like that. Not exactly, but you should be able to kind of figure it out based on the ones that we have done. But if you get stuck, just ask.